So in this video we will talk about the covariance. Covariance is a very important topic in the statistics. It is widely used when we are doing data processing, when we are doing predictive modeling, or when we are doing forecasting in the statistics or the data science problem. So what is the covariance? Covariance is the concept in the statistics which tries to explain the variability between the two variables. Let us suppose that two variables is x and y. What it simply means is that it is try to find the relationship between the two variables. Let us suppose that we have the two variables x and y. Let us suppose x is the size of the house and the variable y is the price of the house, and these are the size of different size of the house, and these are the corresponding price of the house of this size. And this for the size x1, for the house of size x1 the price is y1, for the house of the size x2 the price is y2. So in the similar fashion, now we want to know what is the relationship between the x and y, that is what is the relationship between the size of the house and the price of the house. Then to find this relationship between the two variables, we can use the covariance. So covariance will try to explain the relationship between the two variables, how the x influences y, or how the y influences the x. That is how the size of the house influences the price of the house, or how the price of the house influences the size of the house. So covariance is simply the concept in statistics that tries to explain the relationship between the two variables x and y. It is very similar concept to the variance. The only difference is that variance tells you how the single variable behaves, but the covariance tells you how the two variables vary. So in conclusion, covariance is the concept in the statistics which will explains you, or the which will provide you the relationship between the two variables, like how the one variable varies with the another. It will give the relationship between the two variables. Now let's look into this first graph. In this first graph, as the value of the x increases from 0 to the positive side, the value of y is also increasing. So this graph have the positive covariance, that is covariance is the positive. If you look into this, they get a graph as the value of x increases from 0, the value of y is decreasing. Of course this x and y have relationship, but they are negative. That is, they have the negative relationships, so they have the negative covariance. Covariance is the negative. And if you look into this graph, x and y here, there is no covariance, there is no relationship between the x and y. If you look into these points, we can see that they have the near zero covariance, because this point cannot show any relationship between the y x and the y variables. So covariance between the x and y is near zero. So what it means here is that, let us suppose x is the price size of the house and y is the price of the house. As the size of the house increases, the price of the house will also increases, right? So this is the example of the positive covariance, and this is the example of the negative covariance, and this is the example of the near zero covariance, or the Now that we know the basic ideas behind the covariance, now it is time to find the formula for the covariance. We will see how the covariance between the two variables can be calculated. Let us suppose that x and y are the two random variables. Then the covariance between the random variable x and y can be calculated using this formula. This formula is the expression of the deviation of random variable x from its mean multiplied by deviation of the random variable y from its means. So this formula can be expanded into its simplified form using some algebraic methods. So this is the simplified version of the above this formula. This simplified version of the formula of the covariance can also be written like this. So this is the expression of x and y. Expression of x and y can be written like this, and the expression of x is this, and the expression of the y is this. So what it simply means is that is the summation of all the random variable x and the summation of the random variable y, and these are not random the values of the random variable x and y, and this is the probability of occurrence of the random variable x and y minus this is the formula for the expression of the x, and this is the formula for the expression of the y. So we have only substituted the corresponding values or the formulas of the expression here. Different formula. With this formula we can use this formula to calculate the covariance between the two variables x and y. When the x and y are not random, can be calculated using this. Now we will study some important things that we need to know when calculating the covariance between the two variables. The first thing we need to note is if the x and y are the two independent variables, then the covariance between this variable x and y will be equal to 0. We said x and y are independent, that is they don't have any kind of relationship with each other. For example, height of the person and the salary of the person are the independent variable because the salary of the person don't depend on the height of the person, right? So the covariance between the height and the salary of the person is 0 because salary of the person don't depend upon the height of the person. Maybe salary may depend upon their education level, their age, but salary does not depend upon the height of the person. So the covariance between the height and the salary is 0. But the covariance between the size of the house and the price of the house is not equal to 0 because the price of the house depends upon the size of the house. So size and height are dependent variables. So the covariance between the size and the price of the house will not be equal to 0. Now the next thing we need to understand is if we try to find the covariance between the same variable, then it is same as calculating the variance. As we already know, variance tries to find the variability between the single variables. So if we try to find the covariance between the same variable, then it is same like as calculating the variance of that variable. Until now, we studied the basic ideas behind the covariance. We also saw the formulas of the covariance, and we also saw how the covariance can be calculated in the very mathematical way. Now, in this section, we will try to interpret the concept of the covariance in the very simple manner as possible. So the first thing that we need to understand is that if the covariance between the variable x and y is large, then we can say that the variable x and y have the strong relationship, that is x and y is strongly dependent on each other. It does not matter whether the value is large negative or the large positive. That is, if the covariance between the x and y have the large negative value, we can say that the variable x and y is strongly negatively related with each other. And similarly, if the covariance between the x and y have the large positive value, then we can say that the variable x and y have the strong positive relationship. Okay, so similarly, if the covariance between the x and y is small, then we can say that the variable x and y have the weak relationship with each other. That is, x is weakly dependent on the variable y. Now the next thing that we need to understand is that weak covariance can become strong in the different scale. and the vice versa. What it means is that for the same variables, when they are in the different scale, we will get the different covariance between the two variables. This concept can be easily understood with the help of the example. Let us suppose that we have the two variables, size of the house and the price of the house. Let us assume that the size of the house is in the centimeter scale. And let us again assume that when the size of the house is in the centimeter scale, we get the weak covariance between the size and the price of the house. Now, let us convert the size of the house from the centimeter scale to the meter scale and calculate the covariance between this size and the price. We can see that when the size of the house is converted from the centimeter scale to the meter scale, we get the strong covariance between the size and the price. So here we can see that for the same variable size, when they are in the different scale, we get the two different covariance. So this is the basic idea behind how the scale of the variable affect the covariance. So we can see that when the same variables are in the different scale, we will get the two different covariance between the variables. So the next thing we need to understand is that covariance only gives the directions of the relationship but not the magnitude. It only tells you whether the variable x and y have the positive relationship or the negative relationship. For example, here the covariance between the x and y is 300. 300 is the positive value, so we can say that the x and y have the positive relationship with each other. But it does not tell you, that is covariance. Covariance does not tell you exactly how strong the relationship between the x and y is. To obtain the exactly how strong the relationship between the x and y is, we can use the correlation coefficient. Correlation coefficient gives you exactly how strong the relationship between the x and y is. That is, it gives you the magnitude of the relationship between the x and y is. So the correlation between the variable x and y can be calculated by dividing the covariance of the x and y by standard deviation of the variable x and y. So in conclusion, covariance only gives you the directions of the relationship, but it does not tell you the magnitude and the. If we want to find the exact relationship, exactly how strong the relationship between the x and y is, we can use the correlation coefficient.